Good afternoon, everyone. I hope you enjoyed the ice cream. I didn't have it, I was too stressed. So, um, welcome to my talk. Let's see if I can get this thing working. So, I'm Jeroen Keppens. I'm a freelance PHP developer, backend developer for over 20 years. I've done Scrum mastering, team leading, project management, all kinds of things. My email address is on there somewhere. And I'll be talking today about a lot of things. And as you can imagine, we cannot go in depth on everything. My goal was to tell you about a road that we've been taking to transform our legacy application. And I prepared the theory and a sample application. And somewhere along the way, this became a 1.5-hour talk. And I have 45 minutes. So I split up the talk in 2 parts. Today is more about the theory and what we did. And if you want to see the sample application, you can join me tomorrow at YoungCon, where I will do the demo and sample application. So if you want to see a lot of code, my apologies, it will not be in this talk. So you're still allowed to go. Otherwise, if you want to see it, I will see you tomorrow. So I'm working at Connecting Expertise, which is a Belgian SaaS application. And it's been being developed for, I think, 10, 12 years. As a lot of legacy applications, it has a ton of problems. Lack of flexibility, very difficult to add new features, lack of information. When something happens, there's not enough logging, there's not enough reporting, whatever. Lack of consistency. What was developed 10 years ago is different from how it is being developed 2 years ago. So the system, you can see really what parts are older than other ones. Because of the way it was developed, it's a very highly complex application with a lot of wires getting crossed, or as we might call it, spaghetti code. There's limited documentation available because there was never time for documentation. It makes it very difficult to test, very difficult to support and maintain, difficult to scale. And somehow, after 12 years, it's still running. But we see that over time, it becomes more and more costly to add new features and to maintain. So while we were doing that, we had a conversation with people from Antwerp University who have been been doing research into software architecture, and we're working on something called normalized systems. And this is how they say it. I'm going to read it because I don't like the sentence. But normalized systems are new modular structures with unique evolvability characteristics where combinatorial effects are systematically controlled or eliminated, with a nice typo, apparently. What it means is, very often when you change one thing in your code, there's a lot of things that can happen, a lot of things that can go wrong. And in their theory, it says, okay, when you change one thing, you need to know exactly how many points are going to be affected and exactly what is going to be affected. What very often is not the case in software development. And so they do this evolvability based on continuous regeneration, rejuvenation of software. And they combine a lot of insights from agile methodologies, aspect-oriented programming, continuous integration, and a lot more stuff. And they build a theory. That's not what this talk is about. But why am I saying this? When we were looking at this, a lot of the goals that they are trying to accomplish is what we wanted to do with our new platform as well. We want to eliminate these combinatorial effects. We want to create a system which is easier to maintain and support. We want to be able to test properly. We want the system to be more reliable, secure, reusable, scalable. Don't we all? And while we were researching this, we were looking for what kind of architecture would fit this. And we started looking on the internet. Oh, I have one more slide. And what does maintainable code means? Well, you need 3 things. Well, you need a lot of things, but these things always come to the front. You want high cohesion, low coupling, encapsulation. And when you're talking about architecture, you will see these things coming back a lot, and different architectural styles are trying to find solutions in different ways. Everybody know what these things are? Let me quickly say. Encapsulation is you are hiding functionality within a class. So when you have something that's being used, you don't care of what it is doing, but only how you have to use it. Second, low coupling. You try to avoid the spaghetti code, the wiring. So you make sure that your components don't interconnect too much. High cohesion. When you have one component doing something, it has to be doing something very specifically and not 100 things at the same time. By doing this, you avoid, with the low coupling, you avoid that one thing can change an unknown amount of other things. High cohesion, you avoid the amount of things that can change. Because you know, I have one specific function, so I stay within this. When we see the architectural styles and patterns, you probably know them. First, there were the monolithical architectures where you put everything together. Well, that works. But without structure, well, it's not really reusable, not scalable. So people tried to add layers. And we got a lot of different architectural styles where they started implementing first just client-server, then MVC, and then even further going to the user interface, presentation, application domain. So people started adding more layers in their code. But scaling horizontally was not enough. People wanted to have one team working on one part of the application, or wanted to scale another part of the application more easily. So they started also vertically organize their code into services. And then you have the very nice patterns. You probably heard about spaghetti code. I think it's fair to say we have all encountered that one. When you're talking about layers, apparently you have lasagna code. There's something about Italians and programming, apparently. And lasagna code is when you have too many layers, or when you have layers that, when you have strict layers and you say a layer can only talk to the layer below and not too many layers below, you get a lot of proxy classes where one layer is talking to another layer, which is just passing a request to another layer, and this is called lasagna code. And when you start doing service-oriented architecture and you're making very small services, and a lot of them, apparently that's called ravioli code. I didn't know that. So when we were looking at what do we want to do, we found a very interesting blog series, which is called the Software Architecture Chronicles by Herberto Grassa, or Grac, I don't know how to pronounce it. He's an Amsterdam-based developer. And I really recommend reading this. It's like 20 blog posts. And I was allowed to use his images in these slides. I've created a sample application based on this whole architecture, and it will be tomorrow at YoungCon, or you can find me at the speaker tables, and I can show you as well. And after tomorrow, it will be available on GitHub on that URL. So, explicit architecture, as Herberto calls it, combines a lot of methodologies, architectural styles into one. When you go to conferences, you have seen talks about domain-driven development, CQRS, hexagonal architecture, or onion architecture, a lot of things. And I always kept wondering, but how do we put these things together? How do you go from D&D with ports and adapters, and well, he talked about that very detailed without the sample application. So let's go over those different things. So who hasn't heard of CQRS? So, well, most people have heard about it, good. In CQRS, what you're actually doing is separating commands from queries. So you are adhering to the single responsibility principle, and when you are changing data, you don't want to return data. When you are returning data, you don't want to change data. You don't want side effects. They do this by splitting these two things up in queries and commands, where the queries, well, I basically already said, return data, don't change anything, no side effects. And the commands, they will do something. It moves away from a data-centric approach in software development to a more process-centric approach. And we do things like event storming. It's really interesting to map out everything that can be done on your application and to really focus on business processes instead of the data behind it. So I should do it like this, apparently. I have this nice laser pointer, but I can only point at one screen, so I will try with my mouse. So your presentation layer has two things. It has access to a query bus and a command bus. And the only thing it knows is when I want to perform a certain action, I create a command. And a command is a simple data transfer object. It only contains getters, setters of data that is required to do something. When it wants to request data, it knows, okay, I want to get, for instance, all contracts from the system, and these are the filters I can use. It fills these objects and put them on the command bus and query bus, and that's all the presentation layer will know. Behind that, the command bus will make sure that the right handlers are taking care of the commands, are taking care of the queries. It might go through the application layer, domain, persistence, but you see these layers, and by splitting this up, it becomes very, very clean. Sometimes it becomes very confusing as well, with a lot of these things I will be talking about. One of the other things you might have heard of is hexagonal architecture, ports and adapters. And when we look at the typical, no pointer, when you look at the typical representation of, for instance, MVC, they create horizontal layers where you have the presentation layer, the business logic, and the data layer. And in hexagonal architecture, to say, okay, let's flip this around. You have data coming in, you have something that's being done with the data, and then you can store it. So let's flip it. On the left, we have the user interface. On the right, we have the persistence layer, and in the center, the application core. So in MVC, this would be, do you see the mouse? Yeah. In MVC, this would be the view layer, actually, I'm sorry. Lost my thread for a second. So we have three blocks. One is the user interface, and the user interface will accept input and interact with the system to perform certain actions and requests. So it always reacts on something from the outside. Then you have the application core, which contains all the business logic. It is also independent of the UI that triggers it. So it might be triggered by a command console, API. It can be triggered by a web application, a web page. And on the other side, you have the infrastructure code. And infrastructure is everything that's external. It can be database, messaging, APIs, external to your system. The flow of control is like this. So you always start from the user interface, you go through your application, you do some persistence, and you give feedback to your user interface. You can talk about this for 2-3 hours, ports and adapters, so I'm going a bit fast about it. So let's say we have here a user or an application, and they're communicating with a web server. We have a user communicating with a CLI application. On the right side, we have a message bus. We have a server. We we have a mailing server, and so on. And what's very interesting is everything from the left side, it is telling the application what it needs to do. It's a delivery mechanism. It is driving an application, it's driving logic. So everything on the left is called driving adapters or primary adapters. On the right side, we have external tools, and they are told by the application to do something. Please go save something. Please give me that message. And so they are driven adapters or secondary adapters. Then you have the ports. What are ports? Ports are interfaces which are part of the application that that describe what the application wants to do. For instance, a repository interface might just be an application saying, I want to fetch a contract object from a database. I want to save this contract model to the database. Or it could be the interface of a service. And what's very interesting, the primary or driving adapters, they will take one of these ports as a constructor, and you can inject application code into your primary adapter. When you're using a command bus model, it's a little bit different. Then you inject a command bus in your primary drivers, in your delivery mechanisms, and you create commands to access the application. The secondary or driven adapters, they wrap around a port. So what this means is, for instance, if you have a real repository which goes to save something, which load data from the database, it will implement the port, it will implement the interface, and it will get injected in the application core. So it's a big difference how the control happens. When we look back at the chart, we can see our command bus here. We can see the port, which are the black lines, and you can see classes using these ports. On the other side, we have the adapters which are injected using the ports into the application core. When you look at the dependencies, there's an inversion of control principle where the application core is unaware of everything that's outside of it. It doesn't need to know, are we using MySQL, are we using JSON, are we using whatever system to store this data? It's injected through dependency injection. The same way, the application, it doesn't know how it's being used. So it can be used within a command console job. It can be used in a web page. It doesn't need to know this. The business logic application core is completely separated. What makes it cool is that everything becomes very testable, because you can mock all the ports, and you can just mock out the whole repository and database saving, and it becomes very easy to test every little bit of your application. Domain-driven development. Another one. So who hasn't heard of domain-driven development? Everybody has heard about it, so we can skip it. No. So I'm just going to pick a few things of domain-driven development, which will be used later on. So the bounded context, it's where you isolate parts of the model, parts of the business logic, to create highly cohesive parts of the application. The size of the context, it depends on your own, the scale that you want, the needs that you have. How do you want to scale the application? How do you want to, how big, who's going to develop it? Do you want to put it on a separate server or not? Or it can also just be based on functionality. And when the bounded contexts are created, they are decoupling everything. So it's creating the vertical, vertical segregations of your application, where each has his database functionalities, has his infrastructure, has his user interface, but that's here, has different layers. So we have user interface on top, then we have an application layer, we have a domain layer, and infrastructure. So it's really difficult to get everything in 5 minutes. So the application layer is responsible for the use case orchestration, and it will create the domain services, entity and value objects to perform certain actions. The domain layer itself contains the entities, aggregates, value objects, and it will contain all the business logic. Well, infrastructure, it's responsible for persistence and messaging. And user interface is everything that the user uses to interact. One of the best ways, well, we saw we have bounded context, but you want low coupling. You don't want the context to have too many wires crossing. And one of the ways that you can do that is, for instance, using events. But when you start saying, okay, I want to use an event in the contract module in a timesheet module, then you need to use this whole timesheet module in contracts. You don't want that either. So you put the events in a shared kernel. And a shared kernel is a shared code base where you put as little as possible, but things that are shared over the whole application. Typically, this can be events. It can also be shared code things, but you want to keep it as small as possible. And it's its own module, its own component. It can contain the same layers, but it's for generic things. And then your modules can just use the shared kernel instead of having the links in between. More about that later. Onion architecture. Who has heard about onion architecture? Sorry, who hasn't heard about onion architecture? Who hasn't heard about hexagonal architecture? Okay, yeah, they're basically synonyms. So onion architecture, it builds on the ports and adapters, but it adds the DDD layers in it. So the image we had before of the ports and the adapters, we had the big application core in the center, but it was empty. When we take onion architecture, we start filling up this empty circle. The layers we are using use the layered approach. So all layers that we have can access layers below, but not on top. But it can access all layers below. So not just the layer directly below, to avoid the anti-pattern called lasagna, exactly. And by doing this, it's very easy to replace both. Well, one of the big advantages of using onion architecture is that it's very easy to replace both the tools and delivery mechanisms, and it creates, I'd say, protection against technology, tooling, and vendor lockdown. What does this mean? When you start creating when you're doing your database stuff and you couple it to your application core, you're practically marrying your infrastructure to your business logic. And how many people have done that? I know I've done it. And it's very difficult to later on separate these two. And when you start doing this explicit architecture, it's a mindset change. The people that will come to see the sample application, you will see there's a lot of classes, really a lot of them. But as soon as you start doing that, you don't know why you did it differently before. Because everything is injected, you can very easily swap out the tools that you're using. For instance, when we were creating the sample application, we didn't have a database to start with. And we just put the data in JSON files. And we had a JSON repository, which just was reading in the JSON file, adding elements. And it was very easy. We could just inject it, and the application was working. And then we started doing the database part. Well, we just replaced the dependency injection to link to the database, and the application was still working. So by doing that, you become very flexible in those tooling. And again, it makes it very testable because you can just mock it. So how do the layers in Onion architecture look like? This is one of those graphs you will see. So they have the different layers. You have the user interface, application services, domain services, domain model, and within the red is the application core, and then you have the infrastructure that's being talked to. If we put that in our graph from before, oops, being too fast, you will see that now we have our application layer inside, and the application contains the command handlers and the query handlers, and the command handlers is what is called by the command bus to handle a command it receives. For me, they are almost like controllers. What they typically do is for instance, they get a request and say, okay, we need to work on object A, so we go to the repository, we get that object from the repository. They get domain objects, which can be an entity or an aggregate, and then they say, okay, now perform this function, for instance, activate on this contract. When this has been done, it will then pass it back to the repository to save and return to the application. Well, we did what you asked for. How it does it, we will see later, because commands cannot return data, which is a tricky part. When we add the domain services, you see the inversion of control going inside. We had the domain services and we had the domain model. One thing about services, we try to avoid using them as much as possible because we want to avoid having large classes with a lot of functionality, fat services. And we try to put as much information in, as much functionality in the entities and entity actions. But domain services have their purpose. When you need to do some domain logic on different entities, on different aggregates, you cannot assign it to one entity, you cannot assign it to one aggregate, so you can create a domain service for that. This domain service can be injected in the application core, for instance, the command handlers, to perform these actions. Application services we've never used, but it's similar. When you don't use a command bus and you don't use command handlers, you can just create application services which do something specific and inject the application services into the user interface and use these. But the way we've been doing it with the command bus, it makes it very clean, because the command handlers become controllers of themselves. They are responsible for one specific thing, and you don't end up with one contracting service which does everything from activating to deactivating to proposing a new person to prolonging the contract, whatever. And instead you have one contract handler, one command handler who will be responsible for the activation, for the deactivation, and it makes it very clean. It makes it also very testable, and it avoids that one class can be broken by one change, which breaks, for instance, 20 functionalities. So the bounded context, well, it creates pizza slices of our application. So it goes through all the layers and it takes out what's specific to one slice of the application. For instance, the contracting module, you can have all business logic regarding the contracting. It's part of one module or one component. Everything around timesheeting, it's one component. If you want, the client I work for, they have a vendor management solution for IT contracting. So they work a lot with contracts and with timesheets. And for instance, when you create a new contract, you want something to happen in a timesheet module. They want standard timesheets be created empty. Well, for that you will, oh, I thought there was one more slide. Sorry. For that you will do that through the events to do the low coupling. But apparently that's later on. Lastly, we have something called events and event-driven architecture. I think after this talk there's a event-driven talk, if I'm not mistaken. I think it's in the same room even. Yeah. I'm not seeing it. Well, yeah, Chris Lye. So if you're interested in events, go look at his talk. Who hasn't worked with events? Who doesn't know what events are? So events are just notifications that something happened in your system. They're classes, and they can contain little or a lot of information, depending on how you want to use that. And events are very good candidates to prevent coupling between components. For instance, if you have component A who wants to react to component B, instead of having a method call from component B on component A where you get the coupling, you can just say, oh, you know, this thing happened. Oh, I want to react on it and go on. It allows asynchronous reactions on actions. It also allows synchronous reactions on actions. But it's also very easy to abuse. There are practically 3 valid use cases. Well, maybe there are more, but there are 3 good use cases. One is to decouple the components. Another one is to perform asynchronous tasks. When we have registered a user, we want to send a mailing out with his activation details, for instance. But also to keep track of state changes, audit logs, or if we think of event sourcing, event sourcing, where you store all the event states and then come to a certain state. Now, when you trigger an event, this is one thing, but you also want to react to these events. And typically there's 2 listeners or 2 ways of reacting to events. You have event listeners, you have event subscribers. What's the difference? An event listener listens to one specific event. It can do multiple things on this, which kind of breaks the single responsibility, but theoretically it can. And it's usually called name of the event plus listener. And then you have event subscribers, and they can subscribe to many events and do something specific. For instance, every time something changes on a contract, we want to log a line in the history table. So whenever there's an activation, deactivation, it's just one subscriber that listens to everything and then goes log it. What are typical uses for events? Yeah, as I already said, event notification. Something happened, we want to do something else. So it's code that will be executed when something happens, and you just give as little information as possible. Maybe you will say, okay, this contract changed. This is the idea of the contract that changed, and that's it. Sometimes you want to carry state. I don't remember, Michael Nowak once gave a talk that I found very interesting, where when you have the different modules, and for instance, a timesheet contract module that I said before, a timesheet module needs contract information, but you don't want these links. So what he would do is, or what his system would do, was they stored a little bit of contract information into the timesheet module. It was a separate table, like timesheet contract, for instance. And whenever a new contract was created, it would then send all the information and all the change data through the event, and the event would store a small copy of the data, but only what was required by the system. And that way you can just within your timesheet module, you can say, oh, this timesheet is for contract with reference 123, and you don't need to go to the contract module. A third pattern is event sourcing. who has used, or no, who has heard of event sourcing? And who has been brave enough to use it? Oh, more people than I thought. So with event sourcing, everything that happens on your system, you log it, and you actually store all entity changes, and then you compute your entity state based on all these changes. And then you have a lot of things to aggregate and historic and having checkpoints in your. Well, I think someone here probably has given a talk about it, and it can be a workshop of 6 hours and still you don't get everything. So when we put it all together, yeah, we get something like this. And I think here's now the event listeners added and the event bus here. Not sure why that's on the right side, but. So if we make a very big class diagram, we get something like this, where you have the view classes, which are controllers, views, view models. You have the commands or the application services and the command handlers, where a controller can create a command, put it on the command bus, where a command handler will take this command and it will do something with it. Typically, it will be injected a repository where it will get a domain entity, which then has actions happening on it. Then the command handler will save it back to the repository, and it will throw an event. Okay, I'm done. This is what I've done. When there's a query, it will go most likely directly to the database. It's something very interesting. What we used to do in the past, we would do queries and then we would create a whole domain object out of it and return that to the user interface. But since we started doing this, we actually returning sets of data arrays or specific view models, and it becomes cleaner, because the view layer very often doesn't need all this overhead from creating domain objects. And if you have to return a lot of data, it can give a huge performance impact. So when you just give data in forms of arrays, it becomes very easy. We're working a lot with table views these days, and all the queries are almost done on specific views. So the data we're getting from the database is a lot smaller, and we simplify our queries by doing that. You can also say, oh, I still want to use classes. Don't use your domain objects because most likely you will don't need them, but create specific view models, and a view model describes the data that you're giving. It can even say this is a date, so your view knows how to display it. But you keep it just very specific for the view. What else do we have on this graph? So then we come to the persistence. So we already said we had the interface of the repository, which is part of the application core. Then we create the persistence, well, the repository itself, the database repository, for instance. And the way we do it, we also have a database mapper next to it. And the database mapper, it has two static methods. And one is go from an array that comes from the database and create an object from it. The other method is the other way around. Take a domain object and create a database, one or more database records from it. And by doing that, you're actually decoupling your business model from your data model. And it becomes very, very clean and very nice, because you can use, you're not bound with how it's in your database in your domain. So tomorrow, or if you want after this talk, you can see how it works in code, which is actually more interesting than this rambling of theory. And so come find me tomorrow, or come find me after this talk. I will probably be in the speaker's corner. It's on the upstairs floor. Or when you're back home, have a look at the sample code. It will be there latest on Monday. And if you want to know more about all this, because I tried to put a lot in 45 minutes, be sure to read this blog post because it contains really a lot of information. So